Now what we have here is a crab called dophia horrida. Now you can see how it got its species name just through the sheer monstrosity of the shape of the claws. But what this guy does is he hankers on the bottom, holding very still, and as you can see here, he looks very much like a lump of rock covered in some coralline algae. The purple colouring is actually his rather than an encrusting algae. Now, very good at camouflaging, covered in some mud or silt, very hard to see unless he starts moving, which unfortunately for this guy, that's how he got found. He was underneath a rock, got turned over, started to move, got grabbed. So these guys are found in tropical Australia, both coasts. Not usually encountered by divers simply because they're very hard to spot underwater. But mostly these guys will be cruising around the bottom looking for shellfish, small crabs, to dine on when they can. We didn't pick this guy up on the last trip, and this is the first time we've seen him on this trip. Normally, seeing as he is hard to find, I hardly see these guys. So they are quite rare on the reef, or at least seemingly rare. It's very hard to give a gauge when not many people pick them up.
We're at Cassini Island, and I'm a phycologist, which is a person who studies seaweed. Phycos means seaweed in Greek. And we're at Cassini Island here and looking at the seaweed populations that grow here. There's probably over 300 species that we're going to encounter. A lot of them have wide distributions along the northwest up into the Philippines and Asia and in the Indo-West Pacific. Just a few examples. This is an unusual one. This is one of the few seaweeds that actually has a common name. It's called sailor's eyeballs, strangely enough. It's a funny looking thing. It's a giant green sphere, and it's actually just one cell. So this whole thing must be one of the largest cells, individual cells known. Very strange thing. It grows on the reef flats. If you puncture this, it'll just collapse and all the liquid will come out. A lot of these green seaweeds are in fact single cells, and I've got two more examples here. This is a thing called alameda, and even though it looks like a very complex plant, it isn't two. It is also one cell, but the cell is sort of drawn out into lots of filaments. This one is actually calcified, although you can't see it. When the alameda dies, it produces it has a calcium carbonate skeleton, and that skeleton falls to the bottom and falls a great percentage of the sediment that you find in coral reefs. In fact, when you look at coral reefs, a lot of coral reefs are, even though the skeleton of the coral reef is made from coral, a lot of the infill is made from alameda skeletons, so that comes from algae rather than the animals. So that's alameda, very, very common, many species in tropical areas. One of the others, another green seaweed, this is a thing called caulerpa. This is a Caulerpa racemosa. I'm not sure if you can see it there. Again, a single cell, so this whole thing here is just one cell. It's a continuous on the inside. Caulerpa is interesting, not this one in particular, but the genus includes some of the worst invasive marine pests known to man. And in fact, a caulerpa from southwestern Australia has somehow been introduced into the Mediterranean and is taking over large tracts of the Mediterranean. It's actually competing with another caulerpa that was introduced probably from southern Queensland, which again, some of the worst invasive marine pests. But for most part, seaweed's pretty innocuous. They're normal parts of the environment. It's a bit unfortunate they get called weeds because they're not really weeds, they're just natural plants. And definitely a wonderful thing to study.